So yeah, there's this polynomial problem and it uses some ideas that I really like in polynomials. So I'm going to show it. Okay, so this is from USA 1974. Yeah, so it's find the all triples x, y, z, three numbers of complex numbers, satisfying x plus y plus z equals 3, x squared plus y squared plus z squared equals 3, and x cubed plus y cubed plus z cubed equals 3. So there's definitely at least one obvious solution. Does someone want to say what it is? Just like, you can DM it to me. It should be fairly clear. Yeah, Kevin?
The solution for x, y, and z is 1.
Yeah.
Oh, the obvious solution.
Yeah, I'm pretty sure it's also fair. I'm not sure if you can, I'm not sure how easy it would be to show that it's the only real set of solutions. But yeah, 111 is the obvious solution. Well, the tricky part about this one is the complex numbers part. But yeah, okay. So the goal of what we're going to try to do here is we're going to try to construct a cubic polynomial like f of w, which has roots x, y, z. It's a nice idea. So yeah, we're going to try to create this polynomial which has roots x, y, z, and then we solve the polynomial and we get the values of x, y, and z. This is like the main idea. This is the cool idea we want to show off. And so in order to construct f of w, we use Vietas. So if we want f of w to have roots x, y, and z, it'll have to be equal to, I hope it's not too confusing having w as the variable instead of like x as the input. Yeah, so f of w equals w minus x, w minus y, w minus z. And this is equal to w cubed minus x plus y plus z, w squared plus xy plus yz plus xzw minus xyz. Okay, all good. And so there's a couple things that we get almost immediately. Firstly, this is 3, just from condition 1. And then we can also get that xy plus yz plus xz equals x plus y plus z squared minus x squared plus y squared plus z squared over 2, which equals 3. This is a somewhat standard, a pretty commonly used trick. So we have those two coefficients, so we're nearly there to fully determining f of w. And just as like a little spoiler, we're going to show that f of w equals w cubed minus 3w squared plus 3w minus 1. And this only has roots 1. The only roots that it has is 1, which means that x, y, and z will all be 1. Okay. So does that make sense? Like, if we can show that f of w, the polynomial with roots x, y, and z, is equal to w minus 1 cubed, then since w minus 1 cubed has roots 1, 1, 1, x, y, and z are equal to 1, 1, 1. And then we just have to do some final little bit of algebra. So x, y, z, it's a bit more annoying to get x, y, z. The way I would go about doing that is just expanding. Wait, how would I do it? Yeah, x plus y plus z. Actually, you don't need to do that. Okay. I've written down, I'm looking back at my old solution, and I have a bit of a magical, whatever, I'll just go with it. I have a bit of a magical, like algebra manipulation that I just like knew. I didn't really want to have to use it, but oh well, here we go. There's an algebraic, there's a known algebraic trick, which is that this expression is equal to x cubed plus y cubed plus z cubed minus 3xyz. I feel bad that I'm using this because this isn't very motivated if you haven't heard of it. Yeah, and so this part is 3, this part is 3, this part is 3 minus 3 from earlier. So then this means that xyz equals 1. And thus we have shown that f of w equals w cubed minus 3w squared plus 3w minus 1, which equals w minus 1 cubed. And so this means that x, y, and z are 1, 1, and 1. So there's a reason why I wrote USA up here. It's actually usamo 1974 number 4. Or 1973. Oops, my bad. But it's like really early. It's a nice problem.